The next part, the part 5, let's start part 5. Here we will discuss, we'll go a little forward in our discussion now to discuss a very important topic about expressions and operators. So these things are covered in the notes also. You can refer to the relevant parts in your notes in chapter 3. So here are the points that we want to discuss under this. We will look at arithmetic expressions. We can also refer to them as algebraic, logical or Boolean expressions. And those are the main expressions that we want to talk about at this moment. Then about operations, arithmetic and logical or comparison operations, assignment operation, bitwise operations, and some other operations related to membership, identity, and so forth, right? And let's discuss them one by one. So we are going to focus this discussion using numeric data types. So that's a fairly simple thing to do. And that's where we want to focus right now, without going to discuss all sorts of expressions. Simply look at all sorts of data types. We focus on numeric types. That should simplify things and to understand the basic things initially. And we can, of course, have expressions and operations using some other data types, for example, strings, lists, and so forth. We are going to discuss them later, right? In the notes, for example, chapter 6, 8, and so forth. Okay. Right. Let's look at arithmetic expressions and operations. Let's look at a few examples again with some interactive session to show certain things. Let's say the Python prompt, shell prompt, we type 3 plus 4.5, you get the answer at 7.5. So that's how usually Python works in an interactive mode, right? So it can be used as a, if you just want to add two numbers or multiply, do some computation, you can simply use this the Python shell for that purpose, right? It's like a calculator. You give something as input, it's computed and result is displayed, right? And 3 plus 2 multiplied by 8. So this is the multiplication, and that will give you 40, right? Okay, so that's fairly straightforward. 3 plus 2, the whole thing is 5, then multiplied by 8. You have parentheses to make this happen first. Then if you say 5/2, so this is slash symbol, it basically means division, and you get the answer as 2.5. And if you say 5.0 divided by 2, again 2.5. Because in Python, if we just divide, it is considered a floating point operation. So the result is shown as a floating point number, even if the operands here, 5 and 2, are integers here. The result is shown as a floating point number anyway, because here the correct value is 2.5 anyway. So here you can also represent one of the numbers or both as floating point numbers. Here in this case, so the difference between the third statement that we input or expression and the fourth one is that here this 5 is represented as a floating point number, whereas here 5 is represented as an integer. But either way, it doesn't matter, they get the same result because the division operation, like this using this particular operator, is a floating point division, right? The values, even though they are integers, they will get converted for the computation, converted into floating point. All right, so let's continue sequence of expressions. So here's a new expression, 5//2, and let's see what happens. The result is 2. So this is 2 slash symbol. So here one slash symbol operator will indicate the normal division. This one slash like that without a space indicates what is known as integer division, or also called flow division. So what does that give us? It simply gives the integer result. So 5 divided by 2, you get 2.5 or 2.5. So you simply forget about the fractional part. You look at the integer part of the answer. And so therefore we call this integer division. We look at only the integer result. We forget about the fractional part, any remainder. Okay. And if you do it like 5.0 / 2, again, still you will get the answer with only the integer part. The remainder is forgotten or ignored or thrown away. In this case, because we indicated this 5 to be a floating point number, the operation was a floating point operation, but therefore the result is shown as a floating point number. Result is still 2. So it's a flow division, or we call it integer division, has taken place, but the result is shown as a floating point value, right? So even if you had 5, you had a 5 / 2.0 here. If you had a like this, for example, if you say 5 / 2.0, right, you'll still get this kind of answer. Because in this case, then 2 is a floating point number. So when one of the operands is a floating point number, basically the overall operation will be a floating point operation, and the result is shown as a floating point number. So you can also have 5.0 / 2.0. This also gives the same result, right? You can try these things yourself. All right. Let's continue. Okay, 7 with the percentage symbol, and then 3. What is this operation? What result will you get here? You get the result as 1. So what is percentage sign? Here we say it's the modulo division. So 7 mod 3, modulo division 3 means 7 divided by 3. The remainder is what you get here. Now this is basically the opposite of this one. Integer division case, you give the answer ignoring the remainder. Now in the modulo division, you ignore the overall result, but the remainder is displayed. Right? The quotient, after the division, the quotient is shown here, whereas in this case, quotient is forgotten or ignored, and the remainder is 1 that is displayed. That is the modulo operation, or the modulo division. And what does this mean? 5 * 3. So just a star here is multiplication, but if you add 2 stars together, means exponentiation. So basically this means 5 to the power 3, right? 5 to the power 3, it is 125, all right? Okay. So here we are showing again, just so that you can remember these things. Flow division or integer division, simply the result in integer, the quotient is displayed. Whereas in the modulo division, the remainder is the result. And exponentiation is the last thing we did. Okay. So these are some example arithmetic expressions as well as operations. So expressions are, so any of these things is an expression. An expression means it has to be evaluated with some operations. So depending on the operands that you use. So here there's a plus for the summation operation and the summation operator here, or the addition operator is a multiplication operator. This is the division operator, and this is the integer division operator, and so forth. So you can call each of these such operators So when you have an operator with operands, right? So for example, this is the operand, this is the other operand, and this is the operator. This is the operator. So when you have in these all examples, all the operators we have seen are binary operators, or you can say binary operation has taken place, means there are two operands. So this operator, for example, has one operand, this one, the other operand is this. So this, the normal way that we write arithmetic operations, binary arithmetic operations, is by placing the operator in the middle, and on the left you write one operand, and on the right you have the other operand, right? But this doesn't mean that all operations have to be like this. You can have what we call unary operators and operations. So for example, if you were to say simply -5. So what does this mean? Now, minus is in this case would be an operator, and 5 is the only operand. So this is a unary operation, we say. So basically what we are saying is 5, take the value 5 and make it negative, right? So -5, it's like that. So that is, we call a unary because you have a single operand. Right? All right. These are some examples. And of course, you can use many built-in functions for various arithmetic operations or expressions. For example, ABS means absolute value. So absolute value of -4 is 4. Absolute value of -3.2 is 3.2. You can get the minimum value of a sequence of a list of numbers like this. The minimum will be returned. So the max, so this mean is a function. These are all functions, built-in functions, ABS or absolute value function, or minimum function gives the minimum of its list of numbers here. -4 is the minimum. Maximum value is obtained by using the max built-in function. You are giving as argument a list of values separated by commas, and the maximum value will be returned. Right? You can use this as well. Okay, what will happen if you mix some operations of different types of operands? I already mentioned this earlier. Now we, in this case, this particular example, right? This example, it's like you have a floating point as well as integer, right? So this actually slide explains that when you use mixed arithmetic, what will happen. So when you have a binary arithmetic operator, binary arithmetic we mentioned, right? For example, when you say A plus B, it's a binary arithmetic operation. Plus is a binary arithmetic operator, because on one side, left side, there's one operand. On the right side, there's another operand. So in binary arithmetic operator, when the operands are of different types, numeric types, right? One being floating point, the other being integer, right? For example. So the operand with the narrower type is basically widened. That means we say it's coerced. It means you are forcefully converting that, the narrower type, to the wider type, which means, for example, if you are combining, if you are performing a binary arithmetic operation with the integer with the floating point number, the narrower one is we call the integer, will be converted to a floating point, right? So, the ideas are given here. Integers are considered narrower than floating point. So the integer operand will be converted or coerced to be the floating point type. And when you compare floating point with complex, floating point considered narrower than the complex. So if you are mixing a floating point operand with the complex number operand, the floating point will be converted to a complex type first. Right? And if you are basically, generally speaking, if either operand is complex, let's say, uh, you have a complex and an integer one, and the other one is converted to complex number. Similarly, if one of them is floating point and the other one is integer, the integer one will be converted to floating point, right? So that's mixed arithmetic. Okay, yes, it's time for you to try the practice problem 2.1 on page 70. Right. So at this moment, just try it and then come back to this lecture and continue from there. So let's look at, so this practice problem 2.1 contains some relevant exercises for you, which will help you to understand things better and see whether you have understood. So a good exercise for you to find out yourself. Okay, self-checking exercise. All right, next type of expressions are Boolean. We can equivalently say logical, right? So here are some examples. We have seen things like this before. 2 less than 3. Yes, it's true. So any operation that results in true or false is a Boolean or logical expression. So here's how you would perform a comparison. 2 equal. This is how you would compare things for equality. Of course, 2 is equal to 2. Therefore, you get the result true. And let's continue. 2 not equal to 2. So this third one here is this is how you check for not equal situation. Whether something is not equal to another. Of course, in this case, it will become false because 2 is equal to 2. So when you say 2 is not equal to 2, it's a false statement. Result is false. And 2 is greater than or equal to 1. Of course, this is how you write greater than or equal to. Remember that. You don't write equal and greater like this. Right? Remember, this is wrong. And the correct method is equal greater. Right? This is the correct method. Similarly, you can have a less than or equal to also. But anyway, so when you do that, that's again you get true because 2 is indeed greater than or equal to 1. And what about this one? 5 minus 1 greater than 2 plus 1. How exactly does this happen really? Anyway, when you try this out, you will feel that you will see that you get the true result, the result of true. So how do you explain this? How exactly does this really happen? What happens here is that this will happen at the very end as the last operation. First, this and this will get evaluated. So 5 minus 1, we know it's 4, right? And 2 plus 1 is 3. And 4 greater than 3 is 2. So therefore, this is correct. Okay. And the reason why this happens like this, it's basically called the operator precedence. So when you have a logical comparison operation mixed with arithmetic operations like this, and this will have higher precedence, or we call higher priority, than this comparison. So therefore, first the arithmetic operations will be completed. The result will be now compared for greater than. Okay. And later I will show you the precedence chart for Python language, which is available in your notes also, right? And continuing this, you can actually, so far on this side, you can see all the operations, the logical operations are single operations, right? You have a single comparison, 2 less, here 2 greater than, 2 less than 3, or here 2 greater than or equal to 1, like that, just one operation. But here you can see you can combine multiple logical or Boolean operations using keywords like AND. Now here this says 2 less than 3 and 4 greater than 5. So what will be the result? False. That's because if you have AND here, for the overall result to be true, this must be true, and this also must be true. Both must be true. Then only the overall result of AND becomes true. Now we know that 2 less than 3, this is okay. This is correct, but 4 greater than 5 is not correct. So this is true, you can say, and this is false. And true and false is actually false. So that's why you get the false result. Right? Using an and if you want to get the overall true result, you have to have something here which result in true, and another thing here also must be true. Then, of course, overall is true, right? And this is basically common with all, whatever way you that you evaluate and in various different contexts, both operands must be true for the overall result to be true. Okay. Right, let's continue. Not 5 greater than 3. So not is another operator that you can use to make more complicated or more complex operations. So 5 greater than 3, the result is we know true, but when you say not, it's a negation. So negation is false, right? Not of true is false. Okay. And you say B comma C, the values are, let's say, 98 and 97. So B is 98, C is 97. This is what it means. Now, if you say B greater than C or C greater than or equal to 100, in this case, you get the result as true. Why? Because in the case of OR operation, this is one overall operand, this is the other operand. So O is the operation as well as the operator. For the O operation, if at least one of the two operands is true, then it's enough. So B greater than C. B is 98, C is 97, therefore this is true. But C is 97, so it's actually, this is not true, this is false. Right? Whereas this is correct, this is not true, but because just one is true, then you get the overall result as true. So that is how O works, right? Or if you're performing an O operation, simply as long as at least one of the operands is true, the overall result is true. When both operands are true, also the result will be true. The result will be false in the O operation if both operands are false, right? Okay, so in this case, we can see AND, NOT, and OR operators can be used to combine various things together, multiple operations, so to complement or negate existing any other logical operation, and so on and so forth, right? And not or are keywords in the Python language. And for further this discussion of these things, we refer to please refer to the sections 3.3 and 3.6 in your notes. Right here we provide some details, and more details can be found there. All right. Now we can actually, you can try the problem 2.2, the practice problem 2.2 on page 18 in notes, right? Okay, so stop watching this video and go to this exercise, practice problem 2.2, try these things out, and after completing that, you can come back and continue from here. The next one we want to discuss is assignments. So the general format of assignment statement is you have some variable on the left-hand side, then an equal sign, and then an expression. So let's look at a few examples. So here's one. And we have actually written these kind of expressions before coming here. We indeed looked at a few examples when we were discussing about mutability and arithmetic examples. All these things we have seen But here's the time we are actually really talking about it in a more serious manner with respect to the assignment operation here. Actually, this is just an equal sign. What does it mean to be an equal sign? Now, this is something, this is a fairly important conceptual difference between mathematics and computer program. Now, in the case of mathematics, right, if you just say something A equals B, it basically means we are saying that on the left-hand side of the equal sign, there's something, and that is equal to the whatever is on the right-hand side, right? As a value or mathematically, they are basically equal, right? That's what we say. But in the case of programming languages, which is applicable to Python or any other language, when you have something like A equals B, or right, or we can say, let's say, take B equals 4. This means there is a assignment operation. We basically say the value 4 is assigned to the variable B. That's what we basically say. But of course, we know from our previous discussion, here we are talking about when you say assign, actually assigning a reference, so we are making an association. So simply, we have an integer object whose value is 4, and B will be a name for that. B will be basically, we say in other words, so B will be referring a reference to 4. But we can also understand this in terms of saying like, okay, B is a variable who will be assigned, who is being assigned the value 4. So the assignment, it's like in this manner, can be written in this manner also, just like an arrow mark. That is why in certain algorithm syntaxes, to be sure, we basically write instead of assignment, instead of equal sign, people use the arrow to indicate the 4 is now assigned to B, right? Because equal sign can mean different things as well, because we saw in Python, the equal sign is used before for what purpose? We have already seen an occasion. We used 2 equal signs like this to check for equality, whether A is equal to B, right? So remember that. So equal sign is used there in that manner. And here we are saying equal sign with a single equal sign, it is the assignment operation. And another thing, very importantly, understand that it has to be, if you do assignment, on the left-hand side, we have to have a variable or a name, and on the right-hand side, the expression. For example, now when you say B equals 4, here is the variable, and here is the expression. You cannot change the two, right? So this is the correct way. You can't say 4 equals B in Python or any other programming language for that matter. Usually for assignment, this cannot be done. It's wrong. If you try to do this thing, basically you try doing it and you will see what kind of error message you get. Okay, so therefore that's the important thing. Now in the mathematics, you can obviously write P equals 4 or 4 equals B, doesn't really matter, right? This in maths, I'll just say maths, this is okay and this is also okay. If the first one is okay, then second one is obviously okay, no problem. But it's different in programming. You can say B equals 4, which is a valid one, but you can't say 4 equals B, right? So make sure you understand, right? Because on the left-hand side, you need to have a variable. Actually, there's another term that we refer to. In C language, is basically, we have seen people, this is being used in various documents and other situations. The whatever constant basically cannot be, we say, cannot be a L value. So it's called L value. So what is the L value? L value is something that can appear on the left-hand side of an assignment statement. So for this kind of thing, you cannot have a constant. So a constant cannot be a L value. That means constant cannot be the left-hand side thing in an assignment statement, right? So L, that's what we mean by L values. Okay. So with that, I think that's the important thing, although you may not think that seriously about this assignment. It is indeed an important thing. So when you say B equals 4, as is shown in this example, when you look at the value of B later, when you just type B, the value of 4 is displayed, which means you can interpret this as like the variable B having the value of 4. But I think when we discuss all these things, also keep in back of your mind what we talked about this objects and their names in the earlier discussion, right? We said that when you say B equals 4, it's that there is an integer object whose value is 4, and B is a name for that. B is a reference for that, right? So when you say B just by itself, it shows the value of the object that B refers to, right? So that's another way of explaining it. So either is okay as long as you understand it consistently. You can simply understand in the manner that we just described, like, okay, B is a variable. When you do this, 4 is assigned to B. And later when we check the value of B, it is shown as 4. That is the value of the variable is 4. Now you can take another one here. Of course, now B is a single letter variable. The name is just a B. And here is basically a word. Multiple letters are included. But this is considered another, basically a variable. So it says count equals B times 4. When you do that, it's there's no error or anything. Simply it's accepted. And later when you type counter, it shows the value of 16. Because B, when you write something like this, Python knows what B is, because B has been seen before. So the Python will replace the value of B here, perform this operation. So this is the evaluation of this expression. So understand that this is how the variable assignment or the value assignment works. On the whatever in the right-hand side expression will be evaluated, and the result is assigned to the variable on the left-hand side. So here it was a very easy, just nothing. It's just an expression value is just 4, very clear. When it comes to this one, the value of B is obtained from whatever the value currently. B is Python knows what B is. Its value is 4. 4 is brought here. 4 times 4 is 16. And overall value 16 is assigned to counter. That's why counter gets 16. And if you try to do this, you get a syntax error. Right? You can try, you will get the same thing. So what is the syntax? You cannot assign to literal here. So 5 is a constant, or we also say literals, right? You cannot assign to that. So that's why I think Python is trying to help you and say that maybe you meant equal instead of 1, right? So here Python is guessing that whether you made a mistake here, whether we actually meant equal, right? Just an idea, that's all. Okay, let's continue. Now, if I type count, maybe I want to refer to counter, which was here, but I mistakenly type count. What would happen? Okay, it doesn't know what it is, right? So Python will complain, say that count, name error. Name count is not defined. It will mean round. Maybe round is a known function or some name that it knows, so it is asking whether you meant round. Right? Actually, we mistakenly typed count, whereas we could have typed counter, but Python doesn't know that, right? So Python is simply just guessing. Anyway, the errors you can see now here for this case, you've got one type of error called syntax error. And here you got some name error, because the name count is not known. So these are, different errors that we come across. We will later talk about some of these situations. We call these exceptions also, right? All right, continuing. Here are some assignment operators. We are looking at only this one, yes. And okay, one other thing I just forgot to mention. It's basically here, you can see, not here, basically something like this, right? Okay, first of all, let's finish this thing. So this is what we discussed in the previous slide, right? This kind of, and this means like C equals A plus B means A plus B will be evaluated. The result will be assigned to C. A plus B assigns the value of A plus B to C. Now, in programs, we write a lot of things like this. Now, here is another occasion where programming and mathematics actually differ. Now, you can't say something like this ever in mathematics, right? Because we know we can't say like this, x equals x plus 1, for example. Can we write this in mathematics? No, this is completely wrong, right? In mathematics. But it's perfectly okay in programming. So in mathematics, yes, this is the case, but in programming, this is perfectly fine. And actually, we do write these kinds of things quite a lot in programs, in loops, and so forth. What does this mean? So this means, okay, again, separate the two things. So you don't say x equals x plus 1 in the mathematical sense. You first look at the right-hand side, you evaluate the value. So you take the current value of x, add 1 to that. The result is basically assigned to x. So the new value of x will be 1 plus the previous value of x. This is perfectly fine. Actually, so much so that we use this so commonly in our programs. In C language as well as in Python, you have a shorthand way of writing it, right? So, for example, this basically means you can basically, as an example, you can write C plus equal A. It means C equals C plus A. You can save a little bit of typing, right? By using this kind of shorthand. Actually, this is equally applicable to minus equal, star equal, and you can also do this division, normal division, integral division, and modular division, exponentiation. For all these cases, you can do that. All right. So that's another assignment operation. That for shorthand, you can write something, the compact way of writing x equals x plus 1 is using something like this. Okay. Further details, you can refer to section 3.4 in your notes. Right, with that, I think it's time for you to do this practice problem 2.3. That goes starts in page 19 and goes on to page 20. All right, let's then proceed to an exercise. So the second part of the exercise. So first part of this exercise is just try and practice problem 2.3. And additional exercise, which I gave you here, explain what will be the result if we input the following method interpreter. Can you guess what will happen? Can you? Now, we actually didn't discuss this as a part of assignment, right? Maybe you could raise that issue. Okay, why didn't you discuss? So anyway, I'm here telling you to find it out yourself. Try to find out yourself. Type this. So only one way to find out, right? You basically type this thing and see what happens. Okay. And what about this one? You say A, B, C equals 3 values here, 23, 3.4, ijk as a string. See what happens. And yet another one. Here, when you use this square bracket, we say it's like a list format. So we give a list of X, Y, Z on the left-hand side. And on the right-hand side, you give a list of 3 values and see what happens. Okay. All right. Let's then go to the next type of operators and operations, bitwise. For this discussion, let's assume the value of A is 60 and B is 30. Now here we can assume that maybe 60 is assigned to A, 13 is assigned to B, or even just assume that in mathematical sense. The value of A is 60, the value of B is 30. Either way, it's fine. And there are binary representations and some bitwise operations. Let's discuss. Now, converting a decimal number like this into binary or vice versa, this will be discussed later in lecture number 7, the data representation. But for now, just believe me, and we can basically say the value of A60 is represented in binary in this manner. We have separated these two, like actually it's can say with 8 digits together, it will be like this. So what I'm saying is A would be 0, 0, 1, 1, 1, 1, 0, 0. But we have separated this from the middle, and this part with the gap we are showing here, right? This gap to improve our readability, to make things easy to read, right? So, but it's actually like this, right? 0, 0, 1, 1, 1, 1, 0, 0. That's the value 60 represented in binary with 8 bits. With 8 bits. So the first 2 digits are 0, right? Okay. Then in a similar manner, the value 13, when you represent as an 8-digit binary number, it will basically be like this, right? Value of B. And let's look at a few bitwise operators. So what do you mean by bitwise operations or bitwise operators? So bitwise operators, one example is you can see here, AND operator. And bitwise AND operator is the ampersand sign which is available on the keyboard. It performs a bitwise operation between these two operands A and B. Right? You perform a bitwise AND operation. So how does this work? You go one by one, bitwise. So for example, this 0 with this bit 1, you perform the AND operation, the result is 0. Because if you perform AND operation between 2 bits, 0 and 1, if both are 1, the result is 1. Otherwise, even if at least 1 is 0, you get the result is 0. So as a result, so 0 and 0 is 0. Right? So we are okay here, we are okay here. And here you get this one and this one. So that's what we mean by bitwise. So for each corresponding bit position, you perform this. So bit 1 and 1 is 1. Here also 1 and 1 is 1. Like that. Okay. So if you go from the right to left manner, we actually number, if you in the lecture number 7, you will basically understand, we can number the bit positions like, okay, this one is 0, this is the bit position 1, bit position 2, bit position 3, 4, 5, and 7. So usually this is how you number the bit positions from right to left. The very first one is marked as bit position 0. Then the last one will be bit position 7. So bitwise operation means in each operand A and B, the corresponding bits are basically taken together to perform the operation. Right? Here, the 4th bit position of A and 4th bit position of B are basically considered together for the AND operation. The result is 0. Right? So I hope that's clear. So another operation is called OR operation. So let's try to understand. Just like earlier case, right? The symbol here is vertical bar. This one. So vertical bar, right? It is on the keyboard, usually above the backslash key, right? We have a key like this on the keyboard. At the bottom, it says like this. Up top, it says like this. So that is the vertical bar, right? Yeah, in most keyboards, it's like that, right? So vertical bar in Python means bitwise OR operation. So we can again see in the case of 0 and 1 together like this, and the OR operation result is 1 because 0 or 1, at least one of the two operands is 1, therefore the result is 1. But when both are 0, here you get the result is 0. Right? So like that, you can the rest. Okay, try it out yourself. And you have yet another bitwise operation. What is this? It's called exclusive OR operation. Exclusive OR operation means what? The operator is this hat symbol, which is usually above the character 6 in the keyboard, right? So in the keyboard, there's a numeric keypad like this. So with the key 6, you will see on top is right, this particular symbol. Sometimes some people call it the caret symbol, or you can say hat symbol. Okay. Right. So the what is exclusive OR? You can see from here. Right? Exclusive OR means if you have 0 and 0, you get result is 0. And if you get 1 on both sides also, result is 0. Right? So that's a difference. Now, in the case of normal OR operation, say 1 or 1, the result is 1. Here you can see that 1 and 1. Here the result here is also 1. Because if what we are saying is for the OR operation, at least one operands need to be 1, then overall result is 1. So when both are 1 also, the overall result is 1. But exclusive OR means when both operands are the same value, the result is 0. But when they're opposite only, or when they're different only, you get the result as 1. It's either like this or this with this. You get the result of 1. Right? These are the 4 possibilities. So when the two operands have the same value, 0, 0, 1, 1, like that, the result is 0. And when you follow all these things with individual bit positions, in the case of AP, you will get the this particular result or exclusive OR. Okay? Right, you can check again yourself whether these things are correct. All right, so let's proceed. Right, here's another one. This is a complement. Now, complement is like a not operation. Remember the earlier, the case of Python's not, we said not, well, we said something 5 greater than 3, not, right? So what that did is a logical thing. So this result in some logical result, Boolean. In this case, of course, it's true, but generally not. Inside, you can have not, and inside some logical statement. And what it does is simply get the result here and complement that, get the opposite of that. That's what it means. So it's similar thing here. When you say not A, but in the bitwise sense. What does that mean? Each individual bit is complemented, right? When you say not A, you can see the 0 bit position here. It's 0 here, therefore it comes 1. And next one, it is 0 here. In this case, therefore complementing, it is 1. And if this is 1, then it is 0. For the 1, this is 0. Right? So that's complementation. And what is the symbol here? It's called the tilde symbol. Like in the keyboard, normally on the keyboard in the top left corner, there's a key with this symbol, the tilde symbol, with very likely in most keyboards, this another this kind of a symbol that can be used as a for certain some special software will have in certain situations special meaning to that, but sometimes maybe people will use it for type something within quotes. But of course, there's a single quote as another key, but it has various other applications also. The same key on the top, you get the tilde symbol. All right. Right. And that's some description about bitwise operators and operations. And there are a few other operations which actually we didn't discuss here. I will leave that as exercise for you to read for yourself. And we have provided them in the notes. Right? Operators like left shift and right shift. So two less than symbols or two right greater than symbols together. It's basically first one is left shift. So for example, if you say A left shift, this means what? That means this take the binary representation, bitwise representation of A and shift to the left everything by 2 positions. Right? 2 positions. That's what it means. So if you let me explain this with this current example here, by taking the value of A, right? Let's say the value of A is given as 0, 0, 1, 1, 1, 1, 0, 0. Now, if you say A left shift by 2, the result will be like this. So everything is shifted to the left by 2 positions. So therefore, this, what happens, the current 2 leftmost things, they will get thrown away, right? They will go thrown away. This one will become 1 here, 2 positions. This one will come here, and this one will be the next, these things. And this 0 will be here, and this 0 will be here, and you will have 2 blanks here. So those, what are those values? Usually you get 0 coming in, and this 0 also coming in. 2 new zeros coming into the right side end. So this is the result of left shifting A by 2 positions. What about right shift? By 1 position, let's say. Then take the value of A here, shift everything by 1 bit position. Then you can see this on a 0, the 0th position one will get lost because that was thrown out, and you get as a result next one 0, 1, 1, and 1 from here will be coming in. And on this side, you get last one 0, 0, and a new 0 coming from the left side. So this will be the right shifting of A by 1 bit position. Okay, anyway, so that's an additional description. Although I asked you to read from the notes, I showed you this example, right? Left shift, right shift. Okay. So that's discussion on bitwise operators. So a couple of things remaining. One is the membership operator. If you have a sequence of elements in a list or string or something like that, you can check for membership. You can simply check whether a particular element is inside the other some sequence. Maybe, as said, a string, a list, tuple, whatever. So if it is there, then you get the true as a result. Otherwise, you get the false as the result. So, for example, if you say x is y, that means the result will be true if x is appears as one element in y, as a member of y, and it's a membership operator. Not in means the opposite of that. So if you say x not in y, it means the result, the true, will you will get if x is not a member of y, right? And then you get the is operator, which we have already seen. It simply means when you say x is y, it means it will compare the identity of x with the identity of y, and you do a comparison operation. The result is what you get as x is y. Again, you can say is not, basically check the opposite of that, right? If the true result will happen if identity of x is not equal to identity of y, right? Okay, and then we have the operator precedence. So this is available as a table in your notes also. Overall, the priorities. So at the top, you get high precedence. At the bottom, you get low precedence. So going down will be gradually lowering the precedence or priority, and going up, it's increasing, right? That's what it means. So for example, the highest precedence is for the exponentiation operation. Next, you get the unary plus and complement these things, right? Unary operation. For example, if you say -5, that has a fairly high precedence. Then, of course, you have various division operations, and then addition and subtraction, right? So this basically means, let's take a couple of examples. Now, if you want to have your own way of ordering or something, you can definitely use parentheses for that. Let's say you want to say A plus B multiplied by C. If you want A plus B to happen first, you have to use parentheses like this. If not, what will happen is, if you don't use parentheses, what will happen? According to this table, this has higher precedence than this. So B star C will happen first, because star multiplication has higher precedence than plus. So B star C will happen first, and the result will be added to A later, right? So that's what I mean by precedence. So anyway, one important thing to remember is, if you are not sure, you don't have to remember, you don't have to memorize this table, but the general idea is enough. Normally in mathematics anyway, also, if you say mathematics, you don't want to write star here. Let's say if you write 9 multiplied by 7 plus 5 or something, we know that 7 plus 5, we don't do that first, right? We normally do 9 plus 7 first, and then the result added to 5. So is still there. If you want to change that, or if you want to make sure, you can always use parentheses. All right. Another observation is that you can see various bitwise operators are here, right? Bitwise operators, they have lower precedence than the arithmetic operations here. Note that, right? And these comparison operators have even less precedence, right? Lower precedence than arithmetic and bitwise. And you can see the assignment operators have very low precedence, right? So the last thing you might do, if you have a combination, like say if you write expression A equals, and you write a lot of things here, right? Plus, minus, whatever, multiplication, all these things. All these will be considered. And finally, you do the assignment, which makes sense, right? So that's what you should actually be doing anyway. So that's basically the how the assignment. And at the bottom, you basically have other things, is not, need not, in, not, o, and. That's another interesting thing, right? You get this, right. So the last one, basically, you can see not, o, and have low precedence, right? Very low. All right. So with that, we can let me just erase these things. All right. With that, we conclude the fifth part of the lecture number 2.